So today we're going to talk a little bit about surface water, and immediately most people, when you talk about water on the surface of Earth, they think fresh water. But in reality, when you think about the majority of water on Earth, really think about it, most of that water is salt water. It's got salt in it, and it's traditionally found in the oceans, although there are some inland saltwater lakes. The majority of the water is saltwater. In fact, almost all the water on Earth is saltwater. Very little is freshwater, only 3%. So where is that fresh water found? Again, a lot of people kind of go to things like rivers and lakes, and definitely there are good amounts of fresh water in those locations, but the majority of fresh water on Earth is actually locked up in ice, whether it's at polar ice caps or in glaciers that we still have today. That water, a majority of that fresh water is locked up in ice. Now, you might be thinking, well, the Earth is getting warmer. Isn't that ice melting? It definitely is. But when you think about polar ice caps and even many glaciers, they're found either right next to or very short distances from the ocean. So when that ice melts, it's just going to flow downstream into the ocean and then be added to the glut of salt water that we have on planet Earth already. So a majority of the fresh water that we do have is still currently locked up in frozen ice form. About 30% of the fresh water on Earth is in underwater holding tanks, what we call groundwater. Technically, it's called an aquifer, but groundwater is generally the term most people are familiar with, where water is locked up in rocks or different types of materials underground. And then when you think about those lakes and rivers that you probably pictured pretty early on, only about a little over 1% of that surface water is available in kind of these lakes and rivers and streams and things like that. So when you look at accessible surface water, you can kind of see the breakdown there. A lot of that surface water is available, but in frozen form. So a lot of parts of the Earth hold on to water, and they hold it for a long, long time in freshwater form, in the form of solid ice. You got your lakes, rivers, swamps, marshes, making up a little bit under 25% there. And then you have kind of these smaller amounts inside of things like soil, water vapor in the atmosphere and air, and then water inside of living creatures like you and me and plants and animals around the planet. So then we get into the water cycle, how water basically is transported and moved around. If it wasn't for the water cycle, pretty much all the water on Earth would end and just remain indefinitely in the oceans. The water cycle helps move that water around, distribute it, but also removes some of that salt material as well, making it available for a wider variety of plants and animals. And yeah, I know there's plants and animals that live and flourish in the oceans, but they're not the only form of life. And there are many types of creatures, humans included, that simply can't process salty water in any meaningful way. So a lot of plants and animals require fresh water to live, even though there are some plants and animals that have kind of learned to live with that salty water. So back to that water cycle, the three parts that most people are already familiar with are these three parts here. We have evaporation, condensation, and then precipitation. So evaporation, just to review, is where water is heated up by the sun or some other heat source, and then it is turned from a liquid into a gas form, and then it exists in the air. It's totally invisible to us. You can't see water after it has evaporated until it gets to that next stage, which is condensation. That's turning that gas form of water or water vapor back into a liquid form. So this happens in conditions where clouds are forming. That water is basically squeezed out of the air, it latches onto dust particles or little bits and pieces of sand or even sea salt, pollutants in the air, and it begins to form clouds. So if you can see it in the form of a cloud, then you know that water has been transitioned back into liquid, sometimes even solid form in the case of clouds. Once those clouds generate particles of water, whether it's solid or liquid or a combination of the two, in large enough amounts, then those particles start getting bigger, they get heavier. It's more difficult for the air and the wind to keep those particles of solid or liquid water up in the air. And then eventually there kind of comes a tipping point where those particles are just too big. And then we have the third stage called precipitation. And that's basically solid, liquid, or a combination of the two, water falling out of clouds and heading down towards the surface of Earth. Two pieces that I wanted to add in here that don't often get mentioned, especially in younger grades, are transpiration. Here you can see these squiggly arrows coming out of trees and plants and bushes. A surprising amount of water is transported through these plants on a daily basis as part of the living process of plants, as part of their photosynthesis process as they generate a food source, an energy source for themselves. A lot of water is used in that process. It's pulled from the ground via the root system and then transported through the plant or tree and then eventually up into the atmosphere. So we'll kind of add transpiration onto evaporation, but basically it is evaporation through or with the help of plants. And then we have this other part kind of hidden over on the side. When you think about water that falls from the sky, there are essentially two things that can happen once it hits Earth's surface. If it hits kind of a hard layer, think like a blacktop parking lot or driveway or a concrete road, those are generally impermeable to water, meaning the water doesn't just soak into them. So water will run off. It'll collect, and then typically, storm sewers will carry that away. If you have a really heavy rain, then that water will kind of pool up for a while until eventually it finds a location where it can move on or run off over the land into something like a river or stream and then move along its way. If it encounters an area of Earth where it can actually soak in, a area just covered in dirt or soil or plants or trees, somewhere where it can soak in to the ground, then we call that infiltration. Sometimes it's called percolation, but infiltration, I think, makes a little more sense to most people because it's kind of filtering into or soaking into this area. And then that's what replenishes our groundwater system, is that infiltration. So just two little add-ons to the traditional water cycle of regenerating and moving fresh water around our planet. Then we'll move into the other part of our surface water notes. And this one is talking more about kind of rivers and streams and lakes and wetlands on the surface of Earth. So when you think about surface waters, fresh water is in a majority of these surface water areas, as long as they're not oceans. So things like rivers, streams, lakes, ponds, wetlands, those are typically always going to be associated with fresh water. They're vital. They're essential for a lot of very important ecosystems that support plants and animals. They're also very important for kind of moving and also cleaning a lot of water. As it goes through things like wetlands, it's kind of a natural filter that takes out a lot of natural and man-made pollutants that enter into the freshwater system. So, if we have healthy rivers and streams and lakes and ponds and wetlands, that really is a benefit to all life, and certainly human life is a part of that. So, talking about rivers for a little bit, unfortunately, this year we're not able to go on the river field trip. We'd love to do that with you, but with all this stuff going on, we're not able to do that. So we'll talk a little bit about some of the things we would have discussed on that trip, and just how rivers work in general. The only thing, whether it's a river or stream or anything in between, that causes water to move is gravity. So if you have water in an area, it's just going to sit there unless there is some slope to the land that allows it or forces it to flow. So it's possible that a new river or stream could form if the geography of the land changes, or sometimes you'll see this, when a new subdivision goes up. If there's not a lot of thought put into the planning, it can really kind of mess with where the water will flow and where local rivers and streams will flow as well. And you have to be careful with that because obviously water is a big eroder and can cause a lot of damage and a lot of issues if you don't consider, well, where can this water soak in or where can this water flow, as you kind of change the geography or landscape a little bit by just adding different features to it. So a couple river terms for you. Source. If you think of the source of something, that's where it's coming from. Well, the source of a river is where it begins. It could be a situation where you have a groundwater fed body of water like a lake, and then that over time will kind of overflow its banks and possibly form a river. Or it could just be an area or part of the land that just is shaped in a certain way that it collects and concentrates water into a stream, and it has kind of a general average starting point. That would be the source of that river as well. The mouth of the river is where it enters another body of water. So each river and stream, as it meets the next body of water, that river or stream will end, and then it will feed into this typically bigger. As you move downstream, things get bigger because there's more water volume. So every time a river or stream contributes its water to the next body of water, that's considered the mouth of the stream or river. And that's where that body of water ends, and then the next one continues on, just adding the contents to its water. Moving water, you may already know this, but it is a great eroder and kind of changer of the landscape. If you've ever had a situation where there is fresh dirt or maybe a new building put up, typically there's a lot of kind of erosion control that construction companies have to do until kind of plants will come in and they will help stabilize the soil and things like that. But left to their own devices, moving water can move a lot of dirt and soil and rather large rocks as well. And anything, whether it's big or small or somewhere in between, that a river picks up and moves is called a load. I always remember that, if you have a pickup truck or a semi-truck, something like that, picks up a load, takes something, moves it somewhere else, and then drops it off. Typically, the more water you have and the faster that water is moving, the larger the load that body of water can hold. And then, on the flip side, the slower that water is moving or the less water is available to move these loads, the smaller the objects that body of water can carry. So, moving on a little bit to different parts of the stream or river, we have something called a floodplain, which is basically an area that if and when the river or stream does flood, this is the area that will get flooded in kind of your typical flood situation. So normally it's pretty nearby the river or stream, and it's also not at a very steep slope. It's at a similar elevation to that river or stream. That's what's called a floodplain. Another thing is that you can actually tell the relative age of a river or stream based on the speed of the water to some degree, but also the kind of shape of the river itself. The wider, curvier streams typically have a little slower moving water as well. They're not, known for those fast whitewater rapids, things like that. Typically, those are going to be your older streams or older rivers. The curvier they are, the wider they are, the slower moving they are. Those are your older rivers, more established rivers or streams. If you kind of compare that to a younger river or stream, typically you're going to have faster moving water because you're going to have a steeper area, steeper slope, and those rivers are also going to be rather narrow. They do perform a pretty rigorous cutting action because they're very concentrated, and that fast moving water does pick up a lot of materials along the way. But usually the straighter a river, the more narrow a river, the faster moving the water in that river. Typically that's going to be a younger river or stream. So it doesn't really vary that much to kind of your human life cycle. The younger people out there may be a little skinnier, a little more narrow, a little faster moving, and then as us old folks get older, sometimes we get a little bit wider if we don't keep up with our exercise, and a little slower moving as well. So, like I said, rivers and streams are kind of a little bit similar in that case. Then, you might be wondering, how do rivers and streams get water? It really, again, is dictated by the landscape. So if you have kind of a high area of land and a lower area of land, well, that high area of land, unless the water falls very, very slowly and it just soaks in, typically, if we get a heavy rain, a hard rain, or rain for a long period of time, that water just can't soak in quick enough, and then you get that runoff happening. Well, where is that water going to run off? It's going to run off downhill. And then at the bottom of that hill, you're going to have a collection point where all that water will kind of drain to. And that's the idea behind something like a drainage basin or a watershed. And when you think a little bigger picture, bigger than just your backyard or the area that you like to go hiking or hunting, but you think a little bigger picture, the most dominant river system in kind of the central United States is far and away the Mississippi River. And when you look at this map here, this area in green is where all of the water that falls eventually, if it doesn't soak into the ground and it forms runoff, eventually it makes its way into the Mississippi River before it's deposited into the Gulf of Mexico. And that's a substantial amount of water. So the further down the Mississippi River you go, the more water drains into that river or is kind of shed or dropped off, deposited into that river system. And that's the idea behind a drainage basin or a watershed. The area of land that separates these watershed areas are known as divides. And how do they divide? Well, basically, it's just dictated by their geography. If you have, picture in your mind for a moment, just a very simple mountain, okay? And there's rain that's falling at the top of the mountain. Well, imagine rain falling on the top of the mountain. If it hits one side of the mountain, it's going to flow one way. If it hits the other side of the mountain, it's going to flow the opposite way. And that mountain then becomes a divide. It's splitting. It's determining where that water is going to flow. It's separating out. This water goes this way from this other set of water that falls in a different location will go a different way. And one of the most dominant divides is actually a continental divide in the United States, and that's the Rocky Mountains. So water that falls on the east side of the Rockies generally is going to flow a little bit to the eastern side. And you can see the Mississippi River really benefits from that because it has the Rockies to the west. It has basically the Appalachians to the east, and then in between is this area of relatively kind of moderate elevation land that just acts as a giant collection or drainage basin or watershed for the Mississippi River. So that makes the Mississippi one of the largest volume and most powerful rivers, in the United States by far. So then we get into lakes and ponds. Typically, lakes and ponds are going to be kind of maintained by the groundwater system. They hold water, and over time that water evaporates. They need to be replenished, and typically that's done by the groundwater system. When you think about lakes in our area, certainly Wisconsin has quite a few lakes, but if you look around the state's borders, the Great Lakes really kind of dominate the landscape in kind of this northeastern United States area. And how were those forms? How did those depressions, those great big areas of land, get pushed down? It was really a result of the last ice age. Many thousands of years ago, glaciers kind of pushed in to this area in the Michigan, Wisconsin, Minnesota, New York, Ohio, Indiana, to some degree Illinois a little bit, area, and really kind of changed the landscape as those huge walls of ice kind of pushed through and change the geography in this area. And then as those glaciers retreated, they left all that fresh water that was locked up inside them behind, and then kind of backfilled those depressions that they made as they moved in and then back out, and then helped form those Great Lakes. So that's glaciers are really responsible for making those Great Lakes. And then finally, something I referred to earlier on, wetlands, things like marshes, swamps, and bogs, really act as natural filters. They're great because they slow down the movement of water, so they can actually help mitigate or stop floods, or at least slow the water down before it rushes into a river or stream, and give that river stream time to kind of evacuate water that's backed up maybe. But it's also great places for plants and animals to really live and thrive. A lot of diversity, a lot of kind of food sources brought in by that moving water, and obviously plants really flourish with a good water supply. So watersheds, wetlands can really help with biodiversity and just make a great ecosystem for a lot of creatures, plant and animals, and to some degree even benefit humans from that biodiversity that comes out of wetlands. So that is a little bit of information about surface water. Feel free to watch the video again if there's anything you don't feel you got the first time. And if there's anything that you're wondering about that wasn't mentioned in the video, feel free to reach out to your teacher to ask a few questions.